All right, good morning. So yesterday we looked at graphing basic absolute value graphs. So today we're going to look at translating them. Translating basically means move up, down, left, or right. The majority of the ones we looked at yesterday were all pretty similar, right? So for example, we had kind of our benchmark here, right? Absolute value of x, we said looked, right, like this, right? It had that V-shaped, that started at the origin. Right, and then we had some other graphs looked pretty similar, right? So something like absolute value of 2/5 x, let's say, would look kind of like that. 3x or negative 3x, we said is going to look a little bit narrower, right? We can say thinner, but technically we say narrower. And so on. Right now, these graphs all kind of they look the same in the sense that they all started at the origin. Yeah, number 4 is going to flip kind of upside down, so it opens downward, so it's going to look just like the blue one, except it's going to be kind of the mirror image. But we didn't move them around, right? They always started at the origin. So we're going to talk about what we would have to do to translate them, meaning to move them, right? So here's an example where I've got absolute value of x and then absolute value of x plus 3. So of course, absolute value of x, we know exactly what that looks like. That's our benchmark. And now absolute value of x plus 3. So we'll say, all right. So if I use my normal values here, it's going to look like this. So negative 2 will go up to 5, and then 4, and so on. All right, so what did we notice? Well, my red graph is exactly the same as my gray graph, except it's 3 units up, right? So we shifted the entire graph 3 units up, and the reason that we would shift it 3 units up is that there's a plus 3 at the end of it. So I'm sure logically we can figure out that if there was a minus 3, that it would go 3 units down, and it would look more like that. All right, so that tells us something about translating, right? I don't want to have to make this whole table unless I have to. So if I know what the original one looks like, right? If I know what my kind of benchmark here looks like, and that's the gray one that I've got, if I've got plus or minus a number, all I need to do is either push it up or down. So this part we're going to get in our notes because this is really important. All right, the absolute value of x plus k, right, where k is some number, translates our original graph either k units up or down, whether it's positive or negative. So if k is positive, it moves it up. And if k is negative, it moves it down. All right, so that you're going to put in your notes, which means you guys should all be able to check this with your calculator. So we would expect the minus 4 mean that it's going to go 4 down. And sure enough, if you go to your calculator, and again, you go to your calculator and then math, and then the first one there, which is ABS for absolute value. You can also go to catalog. So if you go to the catalog on your calculator, that's where every single function that your calculator has is in the catalog. It's kind of like an index or a directory of everything. And you could go all the way down. Actually, it's not that far down to ABS. And sure enough, when you graph it as expected, it will look like this. All right, now that's going to be our vertical shift. Now the horizontal shift is difficult. Difficult in the sense that it's just not what we would expect. Right? So in other words, on the y-axis, if you say, think about rise over run, if I'm rising positive 3, we're going up. So this is going to be a little bit counter to what we would expect. So we're going to start graphing, and we're going to say, well, this looks kind of strange. And we're going to say, something's wrong, right? I probably didn't go far enough on the negative side. And if we do go far enough on the negative side, it ends up turning there. And we say, okay, well, that was odd. For 1, it shifted horizontally, right? Okay. But not maybe the way we would expect, right? If you asked me, okay, a shift of positive 3 on the x-axis, I would say it's going to go 3 to the right. It actually did the opposite. It moved the original graph 3 units to the left, right? If we think about our benchmark, which again is absolute value of x, which we've seen a lot of so far now, right? The blue one got shifted 3 units over to the left. Now, why did it do that? Well, it's kind of strange, but in other words, in order for us to be on the x-axis, what's in the absolute value has to be 0. And for that to be 0, this would have to be -3, which puts our vertex at -3, 0. That's the technical side of it. Not super important, but that's why it happens. We just need to remember that it happens and that it's not what we would expect. It's the opposite of what we would expect. So again, very important that we're going to put this in our notes, right? That if we have something inside the absolute value symbol, it's going to move it the opposite of what we would expect. So if it's positive, it's going to go to the left. And if it's negative, it's going to go to the right. So let's take a look. So you're going to put that in your notes. We can check this using our calculator. So a -4 in the parentheses tells me this should go 4 units to the right. So if I go 4 units to the right, this is what you should be looking at in your calculator. All right. And again, if you do put that in your calculator or even make the table by hand, that's exactly what the graph's going to look like. So now our goal here going forward is not to do any graphing, describe the shift. So we're talking up, down, left, or right. Okay, so I'm going to say there's a -5 outside the absolute value. It's going to shift 5 units down. I don't need to graph it. I should know based on what we put in our notes already that this should move it 5 units down. All right, now I've got a -5 inside. So if it's inside, I know it's going to be left or right, but I know it's going to be the opposite of what I would normally think. So I would normally think negative goes to the left, which means this is going to be 5 units to the right. And again, you can always check this using your graphing calculator. Now, this was on a Regents exam a couple years ago, and this is one of the last things I review at the end of the year because it's always on the Regents. It's always a 2-point question. So I had, literally the day before the Regents, I had gone over all these shifts. I hadn't done one with a variable. And sure enough, this was on the Regents, and students panicked. And they were like, I know what to do. I know that it's inside. So positive means it's going to the left. But how many units is it? And they didn't realize that a variable is just a letter that represents a number, so it should be a units to the left. All right, now we've got 2 shifts. So I'm going to do the easy one first. So the +2 outside means it's going to go 2 units up. The -3 inside means we're going to go 3 to the right. And then we have the double shift with the variables. Again, panic sets in, then we realize, wait, this is really not any different than the last one. If I've got a +b outside, that means it's going to be b units up. And if I've got a +a inside, it means I'm going to go a units to the left since it's positive. All right, so now you're going to do this in your notebook, right? Describe the shift. So what I would do if I was you is I would pause it so that you can actually do it, not just steal my answers, right? And then we can just kind of dictate it, right? So for the first one, -4 means I'm going 4 down. +b means I'm going b units up. +4 inside means I'm going 4 units left. The -3 outside means I'm going 3 units down. The -1 inside means I'm going 1 unit to the right. Positive D outside means I'm going D units up. Positive C inside means I'm going C units to the left.